Assalamu alaikum, guys.
Waalaikumsalam.
How are you, Mr. Kazi, Mr. Amar?
Alhamdulillah, good, sir.
Oh, thank you. So, have you any question in the previous lectures, or I move to move forward? Okay, okay. From today, basically from the tomorrow, yesterday we have to start the PVsyst lectures. But before going to the start of the PVsyst simulations, we need to know about their losses and other things. Now, basically, we have done the cable sizing like MV, LV, DC string, LV, DC. If we have so, some of the part of the PVC has already covered, like the losses calculation is already covered in the cable systems. Then another thing is the shading analysis, and we have already done through the layout on the SketchUp. So that is why your shading portion is also covered. In that, we will export the DAE file, Collada file, and then we import into the PVsyst and do the simulations. So the losses portion is covered. The individual shading analysis is also covered. Then the remaining part is the orientations of the PV module, PVsyst systems, definitions, and then the losses like the related to the PV modules and inverters and other things losses. So these losses are remainings. So we have to calculate these losses first, then we move forward to the PVsyst. So that is why when you have to do the PVsyst simulation, you have to read how you read the data sheet of the PV modules, PV inverters, MV station, other things. So okay. So now we move on to the our today lecture, and our today lecture is basically regarding how we make the layouts, how we will set the pitch, how we will calculate the string sizing, and then the data sheets regarding the main point of the data sheets. So I'm just sharing my screen, and we start our today lectures. So basically, we will read again these things in our AutoCAD lectures, but today I want to give the information regarding that, like the DC capacity, AC capacity, inverter level, grid level, kilowatt, number of module per strings, mounting structure informations, mounting structure types, the PV module formation, power size, pitch, etc. So what is the DC capacity, Mr. Amar? What is the DC capacity? Amar, are you hearing
सर
me?
यस सर यस आई एम हेयरिंग
What
यू
is the
सर डीसी कैपेसिटी हमारी किलोवाट्स की इन्वर्टर जो हमारी कितने कैपेसिटी का है 3 किलोवाट का है 6 किलोवाट का है तो दिस इज अवर डीसी कैपेसिटी
no, no.
So DC
Mr.
capacity is DC capacity
Yes,
is mainly maximum how much amount of solar power panel is installed. For instance,
okay.
100 kilowatt.
Yes, yes, that's great. Basically, the DC capacity means that the collective capacity of the PV module installed in your systems. Like how many, like we have 700 watt PV modules, one PV module wattage. When we install like the three panels, so means that 3 multiplied by 700, so 2100 watt means 2.1 kilowatt system is installed, DC installed system. So capacity, AC capacity, one is inverter level and one is grid level. Have you any uh, know about that? What is that? Grid level and inverter level? Mr. Amar, Mr. Kazi.
Sorry, sir.
What is AC capacity at inverter level and at grid level?
At inverter level, AC capacity, I think the output of the inverter.
Okay. And grid level?
And grid level is the central load to the grid.
सर
अच्छा
इसमें सर ये होगा कि हमारा कि कितना हम एक तो ग्रिड से ले सकते हैं और कितना हम ग्रिड को फीड कर सकते हैं।
No, no. Basically, basically the AC capacity at inverter level means that like we have 300 kilowatt one inverter and we have installed two inverter. So means that 2 multiplied with the 300 means 600 kilowatt AC capacity at grid level. Oh, sorry, inverter level. But the grid level is that in the large scale project, the grid companies, like if I talk about in Pakistan, the NTDC will limit us that you have to provide the active power. Active. Using the word of active power. How much capacity you have to provide at grid level with up and down of the voltage. With up and down, like 10% voltage up and down, you have to provide that active power at grid level and at any cost. At any cost. So means that like if I talk about any project, like we have 62 megawatts projects, and at grid level we have to provide the 63 megawatt AC capacity at grid level at any cost if your voltage down and up like 10%. Your voltage AC capacity will not go down. So means that we have to provide that and we have to compensate through the war compensation. Mr. Kazi, you are basically from the civil department. So you are maybe not aware of that in war compensation, other things. But I think Mr. Amar will know about that. War compensation, like we have three type of powers. One is active power, one is reactive power, and the third one is the total power. Basically, the KVA rating, like the apparent power. Apparent means the maximum power, but active means the real power. Like if we, I just give to you the simple example of that. Like we have some water in a glass, and some of the actual water and some of like snow type, like some white present at the top of the glass. So means that this white material which is present at the water, it is called like the reactive power, and the actual water, this is called the active power, and total is apparent power. So just in like example of that one, so we have to stabilize the grid, we have to provide the var compensation. Basically var compensation need to stabilize the voltage, okay, to give the active power. Okay, the number of modules per strings, have you any idea?
How much solar panel is connected in a one series?
Okay, thank you. Mounting structure information, like L2, E2 type structure, other things, information like types. Then PV module information, their power, size, uh, and then the pitch. Pitch, what is the pitch size? Pitch, what is pitch?
Pitch is from the starting point of one panel to the starting point of another panel, another
Okay,
row.
that's great. That's great. Though means that basically pitch is like the sum of the total width of the PV modules and then the row spacing which we have left empty. So that is totally called the pitch of that solar systems. So these information are required to make the layout on the AutoCAD and other things. Okay, and then uh, like another. Okay. And then structure edge to edge distance, like in between. I will these explain in the AutoCAD lectures. Then the tilt angle, mostly you know that how many tilt angle of the PV module, height above the ground, lower edge of the PV module to the ground, lower edge of the PV module, tilted PV module, lower edge of the PV module to the ground. This is height above the ground level. Horizontal spacing between PV modules. I will explain these things. I will explain in the AutoCAD lecture. Solid coordinate KMZ files. So this KMZ file is very important to make the PVsyst, to make the layout, because if we don't have the KMZ, we don't have the proper side coordinates. We don't have the proper boundary of that area if we are doing at the ground level. But in the rooftop, we may need some coordinate and marking of that buildings that will give you the idea and you will work on that. This is called an any no-go area. Look, no-go area means that any area which is not utilized for the PV installations. Any shadow object like proper height with trees and other things. This is the pitch I have marked and that. This is basically the clearance between this card. Horizontal spacing between PV module and vertical spacing between PV module. So this is called the vertical. This is clearance between rows. And this is called the horizontal spacing. Distance between the structure. This is called the horizontal. And this is the pitch area. I have just mentioned that one. Then the data collection make like the length. This is basically the for the bifaciality. Okay. So how we will calculate the number of PV modules per strings. How we will calculate the number of PV modules per string. Basically, as per the IEC standard 62548, NXCF, NXCF, we have this formula. This is the formula basically. KU, this one here. VOC cold means KU and UOC. This is basically the formula. Now you have this KU. Basically, UOC means that the open circuit voltage of the PV modules. And this is the cold. At when your temperature at the side is lower than standard test condition, like 25 degree, they will go down. Your voltage will increase. But if your temperature will go up from the 25-degree, your voltage will down. Oh, will down. When temperature is down, voltage up, and your temperature will rise, your voltage will go down. They are inversely proportional to each other. So means that when your temperature is at lowest temperature at side, you have to check that either your voltage is okay for the PV modules, number of PV module connected in one series, or we have to decrease or increase the PV module. We can increase. So KU, we have to first we have to find this coefficient factors KU. So for the KU, we have this formula 1 plus beta V multiply with the delta T divided by VOC. This is basically the formula. So means that now we have to calculate first of all beta V. Beta V means that this is basically, if we talk about, we have solar GIS files in which we have get the data from the client side. What is the lowest temperature at site? What is the lowest temperature at site? So I have find that in the time at 157 day 8:30, the GHI value is 220 and the temperature is 1.6, minus 1.6. So means that when you are a radius, like when you are calculating the PR, your radius should be minimum 100 watt per meter square. 100. When your radius is lower than 100, you will not perform the PR calculation test. So when your radius is higher than 100, you will uh, do the PR calculations. Now you have to check that, and you are check that higher than this radius, your temperature, what is the lowest temperature? So at 220 GHI value radius, I have minus 1.6. It is the lowest temperature. So the above temperature is considered for the calculation purpose as per the IC, because IC has now, as per my PV modules, we have 48.09 is a VOC, V inverter maximum. It is the maximum input, DC input you can put in inverter level input data. So it is 1500 volt. And then VOC temperature coefficient, VOC, this is beta V. Beta V means that VOC, this, yes. So the VOC temperature coefficient is minus 0.24 percentage per degree centigrade. So means that when your temperature will go down, your change in the voltage, VOC, open circuit voltage, as per this rate, means that when your temperature will go like 1 centigrade go down, it will affect through minus 0.24%. 0.24%. So the T team team DBT, it is the lowest temperature. It is the lowest temperature, minus 1.6 degrees centigrade, and the reference temperature is the uh, T standard condition, 25 degrees centigrade. So beta V, how we will calculate it? We will calculate this value as per this VOC. How we will change? Minus 0.24 percentage divided by 100 to convert into value. Then we multiply with the 48.02, 48.09. So this will become minus 0.115416 voltage divided by degree centigrade. Then delta T. Delta T means that T this minus, then minus this value. So means that T dBT minus T standard condition, minus 1.6 minus 25. So it become minus 226.6 degrees centigrade. And then the Ku is 1 point beta V multiplied with this temperature divided by VOC. So when I 1 plus this multiply with this divided by this, we get this value 1.06384. So Ku value is become 1.06384. Then we multiply with this open circuit voltage. So we get 51.1601 voltage. And the N maximum is divided by the number of this value, V in maximum, divided by this value. So we get that around 29 PV module will be connected in one strings. So we have, this is not a your related things. Okay. So how we will calculate the DC string? This is it. You will go, which I have already mentioned in the website, which is doc88. You will go there, find this IC standard 62548 and NXT-F. You will see that this is the overall formula is available. You will calculate how we will calculate the DC string sizing through that formula. Okay. Now we go to the data sheet of the PV modules. This is basically the data sheet of the PV modules. Okay. When we see that, how we will see that value? Like most of you know about that data sheet, how we will calculate the efficiency and other things. Because we don't need about that values. We just need about some important factor from that PV modules data sheets, which is basically this one, this curves. You have seen that, you have seen that it is clearly mentioned that extremely low 1% first year degradation and zero point 0.4 annual power attenuation. Can you uh, explain what is this from your both of you? Can you explain what is this? Extremely low for the first year and zero point 0.4 annual power attenuation. What is this?
The first year will be degraded 1%. For instance, the power is 100 kilowatt, then 1% will degraded, then it will remain
Okay.
99 kilowatt. But after in
Okay.
every year, after the first year, every year the degradation will be 0.4%.
Okay. So at first year, why they will more degrade? Any important factor you will get
I,
from that? Why they are degrading higher than other years?
I don't know, sir.
Okay. Mr. Amar,
सर
Amar,
इसमें थोड़ा सा एक्सप्लेन मैं इस सवाल को समझ नहीं पा रहा ये एक्सट्रीमली लो फर्स्ट परसेंट 1% फर्स्ट ईयर डिग्रेडेशन एंड 0.4% एनुअल पावर अटेन्यूएशन
what is this? I want to ask you, what is this? Have you seen, Amar, how much year of experience you have in this field?
सर सर आई हैव जस्ट in Feb I complete my first year in solar
Okay,
in
first
one
year.
yes
Okay.
yes
And you have, I think you have also see this type of the curves and other things in that field. Because without these, because when we hire some like a trainee engineer, first of all, we
Hmm.
give them the data sheets. Have you seen these values what is the like first year they will decrease degrade 1% the PV module. Other year they will decrease 0.4%. Any reason? Can you explain that?
So it's about the cycle it's a life cycle of panel of PV module.
No, basically, I want to know about why they will more decrease at first year and less
Hmm.
decrease at other year. Why? Any specific reason?
Hmm.
Any specific reason? You know. Okay. Basically, when the PV modules is exposed to the sun at first time, they will decrease at some value at that spot time. When they will exposed to the sun at first time, they will automatically decrease some percentage. So the vendor or the OEM of the PV modules like the Trina, they are actually telling us that they will decrease 1% at first year. So means that zero point 0.4 is the annual degradation. So when they will basically the first year, they will calculate at the end of the first year. So at the when the first year is complete, they will calculate and check that they will decrease 1%. So 1 year degradation is that value 0.4. Other 0.6, what is that? Are you know about that? Anyone from you? At first time when they exposed to the sun, they will decrease. Uh, what we will call that value, that degradation, what we will call them? Amar,
Yes, sir. I'm thinking about this.
have you read about LID factor?
LID factor?
LID loss or LID factor?
No, sir.
Mr. Kazi, have you seen hear about the LID loss before
No,
that?
sir. No, sir. No, sir.
Okay. Amar, uh, you are a senior person in the design field. How much experience they have?
सर एक्चुअली सर डिज़ाइन में तो नहीं कह सकते उनको टेक्निकल लाइक ट्रबल शूटिंग ऑफ इन्वर्टर्स एंड बैटरीज सर डिज़ाइनिंग में तो क्योंकि मैं खुद अपनी एक इंडिविजुअल डिज़ाइन सीख रहा हूँ क्योंकि वहाँ पे हमें ट्रबल शूटिंग करते हैं नो डिज़ाइनिंग वो डिज़ाइनिंग के लिए जो है वो हमारे एक अलग वो है मतलब बंदा है वो करता है
ओके ओके ओके। मीन्स आपका वहां पे मतलब आपको डिजाइन में सिखाने वाला कोई बंदा नहीं है, कोई एक्सपीरियंस गाय नहीं
ये
है वहां?
यस यस यस
ओके ओके
इसलिए मैं
ओके।
इंडिविजुअल क्योंकि मुझे मुझे डिजाइनिंग का था तो इसलिए मैंने खुद इंडिविजुअल मैंने चाहा कि भाई मैं खुद सीखूं इस चीज को तो दैट्स व्हाई आई एम हियर
ओके ओके ओके। सो यू शुड you are searching the things when I am just explaining the other thing. Have you searched or have you studied the things
सर
in
यस
parallel?
यस यस सर
Kindly search the thing like LID factor, what is annual degradation. So you will search these things himself, and I will ask you about these things by tomorrow. Basically, LID is called light induced degradation. Light induced degradation means that when your PV module exposed to the sun at first time, it is called the LID loss, light induced degradation. So means that at first year degradation is 1%, means that 0.4 is the annual degradation, like the continuous degradation, and the 0.6 is the LID factor, LID factor, LID loss. And another main point from that one,
और सर
basically.
जो हमारा एलआईडी सर जो हमारा एलआईडी सर
Mhm.
सर जो हमारा एलआईडी फैक्टर होगा वो न्यू पैनल्स में होगा
Yes, when first time, when your PV module
फर्स्ट
will,
यस
yes, first time they will like exposed to the sun, they will decrease some factors. So these factor will be different for the different PV modules. The P-type PV module has different LID factor, and N-type PV module has different. Basically,
सर ये
P-type PV module will decrease 2% at the first time, first year, but N-type will decrease 1%.
Sir, why does decrease happen?
Sorry,
Why will the power will be degraded?
basically, uh, like I'm, I just say that I don't go in detail like what are the reason behind that, because I don't search about that. I'm not lying to you, but I will check again by tomorrow and give you the proper answer of that questions. But uh, but I know that they will decrease because when the time has passed, the lifespan of the some things. So that is why when the time is passed, like the glass and other things will decrease, and they will uh, like decreasing their lifespan. So that is why they are reducing their powers. And also the things behind that, the doping factor and other things, like in the chemical things, like this behind, because the cells, and maybe some cells will damage due to some issue or other things. So that is the different reasons. But I will like mention these reason in the group, or if I will not mention in the group, I will explain to you by tomorrow in the details.
Okay, sir.
Okay. Yes, Amar.
सर जो आपने कहा कि ये पी टाइप में हमारा डिक्रीज होगा, तो ये एफिशिएंसी होगी हमारी, क्योंकि 1% टू 3% हमारी डिक्रीज होगी कि हमारा स्टेबलाइज होने में। क्या
No,
मैं
no, no,
सही हूँ
no, no.
सर?
Basically, no, 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 no. Basically, I'm saying that P-type PV module will decrease 2% at first year. Means that their LID factor is like around 1.6%. 1.6%. Their LID factor is higher than N-type PV module because their efficiency is higher for the N-type and other things due to the uh, N-type PV modules. So for the P-type, they have LID factor is 1.6% around that one. But for the N-type PV module, they have LID factor is 0.6. So they have the 1% difference. But the annual degradation is around same one, like 0.4, 0.35, like they have the same around that one. Okay.
So, Trina Solar and some other companies are offering the warranty of 30 years, like the power degradation in warranty.
Sorry,
Uh,
sorry. I'm your voice is basically not clear.
okay, my laptop has some problem.
Okay.
When the
What are
warranty, actually, I want to know when the warranty will not work.
warranty? You are talking about the warranty of the PV modules.
Yes, yes, yes.
So basically, warranty means the standardized warranty of the PV module is that, like you can see that they have mentioned the warranty here. I will just explain to you. Like you can see that they have 12-year of the product workmanship warranty and 30-year power warranty. Means that they have the warranty that your PV module will work for the 12-year. Okay. And 30-year power warranty means that they will give you the power for the 30 year. If your system, your PV module is okay, they are not damaged or they are not due to some reason, they will give you the power. But mostly I have seen that this 30-year warranty, first this one was 25 years. Now the PV modules uh, first this like in the previous years, this power warranty is 25 years. Now they have almost all the vendors or OEM of the PV modules, they have changed their warranty from 25 to 30 years. Because you have seen that when in the previous year we have seen the data sheet of the PV modules, there this this graph, like this graph, the degradation graph, is for the 25 years. Now they almost for the 30 years, they will give you the 87.4%. the power at 30 years. Means that. So means that their warranty, so that is why they have changed their warranty from 25 to 30 years. Okay.
Sir, when the warranty will not work? I mean, when we will not be able to claim the warranty?
Basically, the warranty will not claim when like we not follow the instruction from the PV module manufacturer. Like when you will get the PV modules manuals, they will clearly mention that for the cleaning purpose, what type of water and what type of brushes you have to use. Uh, then if we will not follow their instructions, they will not claim their warranty. uh, if you another one point, main point, you have not to disconnect the the connector they have connected with the PV module wires. So if you have cut down and just connect the PV module wire with other wires without that connection connectors which they have provided with the PV module wires, so then they will not claim the warranty. If you have to if the PV module connector are like have issue, you just change that connector to the connector. But if you have just cut down and just use the simple wire without any connector, they will not claim the warranty. And any other reason like some of the hard hard things will damage the PV module, they will not claim their warranty. Like uh, this type of the things, they will not claim the warranty. They clearly mention in the PV module manuals. When you see the PV module manual, they clearly mention that when your warranty will not claim uh, when you will not follow these instructions, like this type of wording.
Okay, okay, sir. Okay.
Yes, Amar, have you any? Yeah, if I will go.
No, sir, go ahead, sir.
Uh, s- okay, okay. So basically, this is basically the powers which I have just talked about. Like in the previous days, when we are doing the cable sizing, what is basically that powers? Like we have peak power watt. Like we have 610 watt, 670 watt, 675 PV modules. So this is the basically the peak powers. And then we have these four values: maximum power voltage, maximum power current, open circuit voltage, and short circuit current. When your circuit or your system in the operation phase, you will get these values. The voltage and the current will inverter will show, or on the SCADA will show these are the values. And if your panels is cut off and they will just place open there, and you just check the voltage through the voltmeter. It is called the open circuit voltage, and you just place the ammeter in the series and just short the wire. You check the current. This is called the short circuit current, and this is the module efficiency. Means that how many number of rays will strike on the cells, and what is the power you gain from that one. This is called the efficiency of that one, of the PV modules. Then we have this 10% irradiance ratio. Means that when your PV module are bifacial, you will get the higher power through that value 10%. Okay, which I have talked about the 10% higher value in the like DC and AC LVDC cable sizing, and I have talked about that we have to include the bifaciality factor. This is basically the bifaciality factor. Rear side value divided by the front side value will give you the 10% time. So means that we have to apply the 10% on the power. Voltage remains same. Remain same. You have checked that. Voltage remains same. But both the cases, open circuit and the operating voltage, the maximum power voltage. But current will like higher than the 10% of that value. And then this is basically the bifaciality factor, like 5% product biofacility. So this is the NOC, normal operating conditions, normal operating conditions. Most of the things now some vendor are not providing these values, but some, but we don't know about their basic criteria. Just they have mentioned that, and when they are calculating these values, they have mentioned that the radius at that time should be 800 volts watt per meter, and ambient temperature should be 20 degrees centigrade. But the standard condition is that standard STC condition, radius should be 1000, cell temperature 25 degree, and air mass 1.5, 1.5, and the measuring tolerance plus minus 3% means that measuring tolerance in the power. And then we have cell, like we have cell that this is one cell, this is one cell. If we calculate this, like we have 1 2 3 4 5 6 in one row, and we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22. So we have 22 in vertical columns and 6 in the row. So means that 6 into 22 means that 132 cells, total number of cells. This is basically the size, the length, width, and these are the installation holes. We have just, you can see that installing hole, you have mentioned that they have installing hole in the PV module. And we have the grounding holes like that one. We have grounding holes on that one. Okay. Drainage holes, like we have to sideway drainage. Okay. Drain hole. And then we have the weight of the PV modules. Then we have the front glass, 2 mm thickness, 0 high transition, air coated heat. Then in, encapsulations. And then we have back glass, like frame size, the J box. This is the J box, basically. This J box means this is the junction box where we have cables like that one. And then the connector, this is the MC4 EVO2, these connectors like. And then this is basically the normal nominal operating cell temperature, 43 degrees centigrade. And this is the coefficients, like we have to analyze these power. Temperature coefficient of the P power max. When your temperature will change, your power will change. Okay? Your temperature will change, your power will change. Temperature coefficient of the VOC, which is I have used in the string calculations. So it is minus 0.24% degree centigrade. And then the coefficient of the IC. IC means that when your temperature, negative means that when your temperature will go down, your power and voltage will raise, because they have opposite values, but your current will decrease. When the temperature will go up, your temperature, your voltage and power will go down, but your current will increase. These are the operating condition, operational temperature, and then we have maximum system voltage and the fuse rating. This is the warranty thing. So this is like we have just these things we have to know about that, the LID factor, and then we have this annual degradation of the PV module to put in the PV module, PVsyst. Then we have inverter data sheets. Like we have inverter data sheets. They have like this different maximum efficiency, smart connector level uh, detection, smart self cleaning fan, IP65 protection, mode bus, smart level, string level disconnections, IV curve diagnosis, and surge arrestor, AC and DC. So our inverter has these functionalities. Like they have the maximum efficiency, okay, and then we have the smart connector level detections, and then we have smart self cleanings, fans. Amar, I just give you some task. You have to like find the IP ratings like 65, 64, 53. You have to prepare one list and share in the group. It is your task to prepare one list of the IP rating and mention their protection against each IPP
Sir,
rating.
how to?
Okay, what are what are you saying?
Okay,
I'm
okay.
saying the IP rating,
Yes, sir.
ingress protection, ingress
सर आईपी रेटिंग्स
protection.
को जो मेंशन करना है,
Yes,
या
you have to prepare one Excel sheet.
यस
You have to mention the
ये
IP
इंग्रेस
rating.
प्रोटेक्शन यस सर
You have to prepare the one Excel sheet in which you have to mention the IP rating, and against each IP rating, you have to mention the protections like dust, water, and other things which the protection will give us. So it is your responsibility to prepare one list and share in the group for the everyone usage. Okay.
ओके ओके
Okay. This is basically the maximum and European efficiency. European means that the average efficiency of the inverters, and the maximum, like we have calculated, get the DC input and convert it to the AC power. At some peak time, it will give the maximum power. This is called the maximum efficiency. But the overall average efficiency of the PV module, how many they will get the DC input and how many they will convert to the AC power, it is called the European efficiency. This is the maximum input voltage, means that your string, how many strings will connect on the PV inverter, uh, how many PV modules will connect in the one string, it will decide that voltage. If your inverter has maximum input voltage like 1000 volt, your string sizing will decrease. But if your voltage level is increased like 1500 volt PV inverter, your string sizing, number of PV module in one string will increase. Number of MPPT trackers means that like we have this 6 MPPT trackers. These are the 6 MPPT trackers. They are installed in PV inverter. 6 MPPT trackers. Maximum power point trackers. And number of strings per MPPT they are deciding. Like we have first MPPT, we have 4 strings, second 5, third 5, fourth 4, like this type of. And this is the maximum current per MPPT. You just give you the 65 ampere current in one MPPT tracker. So you just give you the maximum current per PV per MPPT. So means that if you have 20 degree, 20 ampere maximum current of the inverter, means that 20 multiplied with the 3, so means that you just connect the 3 strings at MPPT. Like large power PV modules, we just connect the 3 strings or 2 strings. But in case of the small PV module wattage, like 500, 400, you just connect the 4 strings, 5 string as per the MPPT ranging. Then we have startup voltage, means that when your inverter will get this voltage 550, then they will start to converting the DC to AC power. Then nominal input voltage means that that is the best voltage level, nominal voltage for the inverters. Then we have the power of the inverters, like active power means that 300 kilowatt, apparent power they have 330 kilowatt, and maximum AC active power at one power factor should be 330. Means that when your power factor will be 1, your active power and apparent power should be equal, because we have the formula. Active power means that active power is equal to apparent power multiply with the cos theta. Cos theta means if you have cos theta 1, means that apparent power and active power will be equal. But if your power factor will go down like 0.95, so you have not equal active power to the apparent power, because they have some reactive power in that case. Then the nominal output voltage of the inverters 800 volt, like AC grid frequency 50 hertz. Then the nominal output current of the PV inverter, and the maximum. Nominal means that this power they have 216.6 ampere, and maximum means 330, they have 238 point. This is adjustable power factor ranging, means that they have the option of power factor changes. So the other has the some protection level, the weight, the IP ratings, and other things. So in case of central inverter, we have like same input voltage, starting voltage, MPPT. Now you have seen that they have just one MPPT, because we have just four inverter in one this containerized solution, because we have four inverters in one containerized solution. So each inverter has one MPPT. I have just explained in the previous classes, that central inverter has one input maximum MPPT tracker, but string inverter has more MPPT trackers. So that is why for we have mismatch losses less than in central in the string case than central case, because when we are connecting more number of string at one MPPT tracker, means that their voltage difference will be higher, because we have like one string has 20 length cable length, and the other string has 100 length. So means that their difference in the voltage drop will affect the mismatch loss creations. So that is for the today. We'll just explain the main point from that one. Now I will sharing these data sheet in the group. You have to study these one, and if you have any query regarding that data sheet, you will ask about that. Okay. Okay. Mark, kindly do by, if you will, it is possible, do it by tomorrow, but
Okay, sir.
maximum by Wednesday.
Okay.
Oh,
I will try,
sorry,
sir.
maximum by Thursday. Thursday. Try to complete it by tomorrow.
Okay, sir.
Mr. Kazi, you have one task.
Okay, sir.
So you have to just collect uh, the data of the PV module structure, because you are doing the like the business, and you have some vendor of the structures in your contact, I think. So you just collect the data of the structures, like what type of structure used in the for the PV module installation in the Bangladesh. So you have to calculate, check that drawing if it is possible, and share in the group. Or you have to prepare one list. What are the what type of structure they are using in Bangladesh? Okay,
Okay, sir.
okay. I think it is up for the today. We will meet
Sir,
again by, yes, yes.
uh, sir, I have little confusion about the central inverter and the string inverter. Why are these are used, and what the differences, and why these two kind of inverters are available?
Basically, the string inverter has lower power. First of all, the difference is that, like, they have maximum up to the 300, 400 kilowatt, but central inverter has like 100 kilowatt, sorry, 1000 kilowatt, 2000 kilowatt, one inverter power. First difference is that central inverter has uh, large power capacity. The other difference is the number of MPPT tracker, maximum power point tracker. Central has one maximum by one or by two, more than. two not possible. But in case of string inverter, they have multiple number of MPPT trackers. Uh, so if we talk about the losses, central has mismatch losses more than string losses, because at string in central inverter, when you will connect the more number of string in parallel with each other, they have creating the mismatch losses more than in case of string inverter, because there are the short number of, like we have connect the 3 to 4 strings per MPPT in string case. But in case of central, maybe we will calculate uh, 4 or 3 or sorry 10 on 10 number of MPPT like strings, or 14 strings, or 15 strings. So they will create the mismatch losses. These are some things, but I will just share the list of the difference between these two things. I will share in the group. You will read out, and maybe if you have to like because these are the to the point differences. If we go in the depth, like we have to study in details the, other things like efficiency difference and other things. Maybe if you go in the detail. Okay.
Okay, sir.
Okay, I will share the data for the central string in the group. You will study, and uh, then you will ask the question if you have any.
Okay, sir.
Okay. Okay, guys. We will meet again, inshallah, by tomorrow.
Inshallah,
Okay.
sir.
Kindly, Mr. Kazi, kindly remind me in the group regarding these two things, like regarding this difference of the list between central and string inverter, and one point which you have asked me. What question you have
Why
asked me?
degradation happen?
Sorry?
Why degradation happens?
Okay. Okay. Yes. Yeah. Kindly remind me in the group. I will share the data in the group.
Okay, sir.
Okay. Thank you. Okay.